Thank you. Topics we have discussed so far. One of you can unmute your mic and can you tell me what are the topics we have completed so far? How many of you have checked in your textbook? I think I have completed the chapter 1 in your textbook. Okay. So what is the need for a database management system? What is the limitation in your file processing? What are the various modules available in your database management system? Who are all the persons associated with your database management system? Actors on the scene, workers behind the scene, characteristics of a database management system, and so in the characteristics, I have listed 4 characteristics. Apart from that, you are having additional features. So all those additional features I have listed as advantages of database management system. And I have concluded with what is the disadvantage in the case of a database system, and when your database system is not an appropriate option, or when to use a database system and when to use a file processing system. So these are the topics we have covered so far. So from today onwards, I will start with the second chapter. So your second chapter is related to, so in the second chapter, the authors have introduced various basic terminologies that will be used throughout the remaining of this course. So mostly today's discussion will be related to basic definitions. Okay. So these are the topics to be covered as part of today's presentation. So we will start with the data model. So how will you define a data model? What is a data model? So what is the idea behind the data model? So each and every data model is associated with various schemas. So what do you mean by a schema? So you will be having a physical schema, logical schema, or low level schema, high level schema, like that. We are having various levels of schemas. And finally, what is an instance? So what is the difference between a database state and a database instance? So these are the terminologies we need to cover in today's lecture. Okay. So before starting with the data model, do you have any idea about client server architecture? So what is the basic idea behind your client server architecture? One of you can unmute your mic and you can tell me the answer. Shweta V.
Sir.
Do you have any idea about client server architecture?
Don't know, sir.
Louder, please.
Sir?
Do you have any idea about client server architecture?
No, sir.
Okay, right. Shivapriya.
Yes, sir. Client server architecture is something about client requesting to server and server responding to the request of client.
Louder, please. I'm not able to hear your voice.
Yes, sir. What I think about client server architecture is client requesting some like client from client side, client request some query and server will respond to the client query.
Same, okay. So your client server is an example for a centralized scenario or a distributed scenario?
I don't know what the sir.
Okay, right. Thank you, Shweta. Okay. So your modern database management system or your modern DBMS packages follows a client server architecture. So it contains various modules. So these modules are organized in the form of a client server architecture. So basically, if you take a client server architecture, you will be having two modules. One is called as the server module and another one is called as the client module. So with respect to your database management system, so what are the functionalities? So the idea is using a client server architecture, we want to create a distributed scenario so that the work will be distributed. So we don't want to keep everything in a single system. So if you run your user application as well as your database application in a single system, the response time will be low. So what we need is, we need to segregate the database and we want to store it in a separate machine. And we are going to refer that particular machine as the server or a database server. So what is the functionality of the database server, or what is the responsibility of your database server? It is responsible for storing the database, organizing the database, and providing search mechanism and providing various access path with respect to that particular database. So these are the functionalities associated with your database server. Then what is the role of your client? So usually the end user, okay, so you are going to sit in front of a system and you will be interacting with the database server from a client system or from a client module. So what is the responsibility of the client module is, or the primary purpose of the client module is to provide various user interface for the end user. So depending upon the on the device, it is going to provide various user interface. So for example, your interface may be a graphical user interface or it may be a menu-based interface. So your modern DBMS package follows a client-server architecture. In the case of a client-server architecture, you will be having two modules. One is called as the client module and another one is called as the server module. So your client module is responsible for providing various user interfaces. Your server module is responsible for organizing and storing the information related to your database. So that is the brief idea about your client server architecture. So next, we will start with the first terminology. So what is a data model, or define data model? So or how will you define a data model? What is the need for having a data model? What we are trying to achieve by using a data model? So what I can say is, one fundamental characteristic of the database approach is the data model. So using this data model, what we are trying to achieve is, we are trying to achieve some sort of data abstraction. So with respect to this context, what do you mean by data abstraction? So here, data abstraction. So we are trying to hide. So by employing this data model, we are trying to hide some details from the end user. So what is the detail we are going to hide? Or how your data is stored in the secondary storage device, how your data is organized in the secondary storage device, that information is not known to whom? That information is not known to the end user. So what we are going to do is, we are going to provide some essential features for understanding the data, or how to access the data. Only that information is known to the end user. So the main advantage of this data abstraction is, so what it is going to provide is, for each and every user, it is going to provide a separate view. So according to their need, each and every user will have a different view of the same data. That is the objective behind the data model. So now, so using data model, what we want to do is, we want to achieve data abstraction. So what is a data model? So your data model is nothing but a set of concepts. So using those concepts, what we are trying to achieve is, we are going to use those concepts to describe the structure of the database. So here structure means what is the, you are going to have some fields, what is the data type associated with the field and what is the relationship among the fields. So using this data model, we want to describe the structure of the database. In addition to that, we want to specify the constraints. So what are the rules that the database need to satisfy? So in addition to this, what you can do is, see, whenever you create a database, it provides, your database management system provides support for some basic operation. So for example, you can create a table, you can select the values, that is insertion, deletion, retrieval. So these are the basic operations. Okay. So each and every data model provides support for what? Provides support for the basic operations. So your retrieval and update comes under the category of basic operations. So now in addition to that, what you can do is, so you can add your own operations. So for certain things, you want to create your own operation or you want to add user defined operation. So depending upon the nature of the application, we want to add our own operation. So for that, what you can do is, see, for example, you assume you are having a student database. In addition to the basic operation, what I need is, I want to have my own operation, namely compute the CGPA. So this operation will be stored in the form of, or this operation will be stored in the form of a stored procedure. So we will be using the term as stored procedure in database. So for each and every student, if I invoke this operation, it will retrieve the what? It will retrieve the CGPA for each and every student. So this depends on what? This depends on the dynamic nature of your application. So depending upon your application, so your recent database management systems provide the user with adding their own operations with the existing operations, or they can add their own operation along with the existing operations in the data model. Now, so the thing is, what we can do is, so if you see this slide, so what is the use of a data model? It is going to use some concept, and what is the use of this concept? This concept is used to describe the structure and the constraint. So based on the concept used, you can classify the data model into 3 different categories. So one is called as conceptual model, second one is conceptual model, and the other name is high level model or semantic model. Second one is called as physical model or low level model or internal model. Third one is called as implementation model, or another name is called also known as record oriented model. Okay, so the thing is, so from the name itself, what you can infer, so conceptual model means it is going to use some concept. So that concept, so how the user will visualize the data. So in the case of a conceptual model, you are going to use some concept that is closely related to your user perception. In the case of a physical model, so from the name itself, what you can infer? Internal. Internal means it is related to your data storage. So it is going to use some concept to describe the information related to the data storage. So what is the record format you are going to use, how it is stored. So in your secondary storage device, that is maybe your disk or in your magnetic tape. So your implementation model is in between what? It lies in between your conceptual model and your physical model. So it is going to provide some concept that can be easily understood by your end users. So we will take the models one by one and we will try to explore what is the concept used in each and every model. We will start with the first model called as conceptual model. So now if you take the conceptual model, so in this model, what are the concepts used? So this model makes use of concepts, namely entities, attributes and the relationship. So to represent the structure of the database, what is the concepts used by this conceptual model, it makes use of three concepts, namely entity, attributes, and the relationship. So first I will show you a diagram, and then I will explain the concepts and then I will explain the terms one by one. So this is an example for simple entity relationship model. So for example, so this is the diagram. So the problem statement related to this diagram is, suppose you assume that you are having an insurance company, so providing insurance for cars. So what is the requirement of the company? The company needs to create a database for storing the information related to various accidents. So that is the objective. So now for this particular problem statement, so this is the ER diagram. So according to the problem statement, what are the information you need to maintain? You need to maintain the information related to what? You need to maintain the information, mainly you need to maintain the information related to the car. Then you need to maintain the relationship, information related to your person. And you want to maintain the information related to various accidents. So if you see the diagram carefully, you are having three different notations. One is I can call this as a square or a rectangle. Second one is the oval, and third one is the diamond shape. So as of now, don't bother about this straight line, this underline and all. Okay. So basically, we are having three notation. One is a rectangle or a square. Another one is a Another one is a diamond shaped symbol, and next one is oval. So this rectangle represents the entity. So each and every entity, so how to further describe the entity? Each and every entity is associated with certain attributes. So these attributes are represented using this oval. Okay, then so if you take this problem statement, you are having two entities. One is car and another one is person. So what is the relationship between these two entities? Or how can you relate these two entities? So for that, you are going to have a relationship. So what is the relationship? Person owns a car. So what are the attributes related to the car? License or your number plate, then your registration number or your model and the year. So with respect to accident, your report number, location and the date. So these are the information. So the thing is, so if you, what is the relationship between accident and the car, accident and person? So this person and this car participated in an accident. So if you don't, if a person doesn't met with an accident, that information will not be stored as part of this database. So what are the concepts used in this model? In this model, we make use of three concepts, namely entity, entity, attribute, relationship. Entity is represented as a square, relationship is represented as a oval, and you are going to have a diamond shaped symbol for your relationship. Now you come to the explanation. So what is an entity? So entity may be a real world object. So it may be a real world object or it may be a concept. So for example, if you take here, your person is an example for what? Person is an example for a real world object. Accident is an example for a concept. So your entity, suppose if you take employee, employee is a physical object. It is a real world object. Project. So employee is related to a project. Or student and the course. So your course is not a physical object. Your course is going to be a what? Course is going to be a concept or a logical one. Okay. So your entity is used to represent the real world object or a concept. So what is an attribute? So your attribute is used to further describe an entity. Or in other words, what I can say is, what are the properties associated with an entity? So you can represent those properties using attributes. Now what is the relationship? So to represent the relationship, so now suppose if you take, you are having an employee and a project. Employee works on a particular project. So what is that? So your relationship. So the thing is, what you have to remember is, in the case of you need, see, this is similar to, this is the water diagrammatic representation of your database. So you will develop a ER diagram as part of your database design. So physically what you have to do is, when you create a database physically, so this will be mapped as a what? A person will be converted as a table, and these attributes will be converted as fields. Okay. So now what you need to have is, you need to have one-to-one mapping. Okay. One-to-one mapping between this what? Between this diagram and the physical structure. So that is the idea behind your conceptual model. So in conceptual data model, see, basically what is the use of a data model? Data model is used to describe the what? The structure of the database. So here, how we are going to describe the database using three concepts, namely entity, relationship, and the attributes. So next one is the representational data model. So actually, this is, so your representational data model is called as the legacy data model. Legacy data model means it is not currently used. So in the olden days, that is in 1970s and 80s, so most of the database management system makes use of these models. So these models are part of your what? Traditional commercial database management system. So what is the concept? Here we are going to store the data in the form of water. You are going to store the data in the form of, a record. So it is also known as what? It is also known as record-based data models. So now, so here, if you take the representational model, so the thing is what? What are the options you have? See, you can represent the, so basically you are going to use record. You can organize this record in the form of a network or in the form of a hierarchical tree. So this is an example for a hierarchical tree. So now see here, so the database, so this is the type, so the thing is what? So you are having a project, so you are having three departments. Okay. So you can call this as a what? You can call this as a root. Okay. So you are having three departments. Okay. So if you take the department one, you are having two employees. Okay. So here employee 1 and 2 belongs to the department A, employee 5 and 6 belongs to the department C. So now here what you can say is, so basically what do you understand from this diagram? So this diagram is used to represent the one-to-many relationship. Okay. So in a department, more than one employee works for a particular department. So here, so this is the notation what you are going to use for the hierarchical structure. So in the case of a network model, same concept. Okay, so same problem statement is represented in the form of a network model. So you are going to have two projects. Okay, so project one, department A and the department. So department A. So you are having two projects. Your department A, department B, and department C comes under the project one. So your department B and department C comes under the project two. So now what do you infer? Your department B and C participates in more than one project. So if you take a project, okay, it involves more than one department. If you take a department, it participates in more than one project. So if you are, so this network model is used to represent the what? This network model is used to represent the many-to-many relationship. So for a project, you are having multiple departments. For a department, you are having more than one project. So this is an example for what? This is an example for many-to-many relationship. So next model is the relational model. So basically in the relational model, your data will be what? Your data will be stored in the form of a two-dimensional table. So you will be having, okay, so you will be having a table name and you will be having the attributes. So in some cases, see, so suppose in this case, so you are having three different tables. You can have a common field among multiple tables. So using that field, you can link that or you can extract the data from more than one field. So now what is the relationship between table 1 and table 2? So here you are having the department number. So here also you are having the department number. So based on this department number, what I can do is I can retrieve the data from what I can combine these three tables based on the common field called as what? Based on the common field called as department number. So these are the models that comes under the category called as representational data model. And finally, the last data model is your physical data model. So physical data model is used to represent the structure related to how your data is stored in your secondary storage device. So what is the file format, what is the record format, how the records are organized, what is the access path associated with what is the access path associated with your table. So already I think in the last class itself we have discussed about the access path. See, the idea is suppose I may ask you a question, what is the need for an access path? So your entire database resides in your secondary storage device. If you want to directly extract the data, the time may be water. So there is a speed mismatch, so the time will be more. How to reduce the time? You create an index. So that index is called as the access path. So you can create an index for your original database, keep the index in your memory. So your index will contain a pointer pointing to the data that is available in your secondary storage device. Again, you are having various options for organizing the index. You can have an index in the form of a water, in the form of a tree, or in the form of a hash table. So in this case, these are the structures used by this model to represent the data. So your data model, based on the concept, you can classify the data model into three categories. One is called as conceptual model, second one is called as representational model, and third one is the physical data model. So next terminology is related to schemas, instances, and database state. So this is a snapshot representing the various tables related to your student database. So now here you are having, for example, you are having 5 tables. You are having the information about the student as well as the course. So this is the content related to what? This is the content related to your student database. So you are having 5 tables, named student, course, section, grade report, and prerequisite. Now, so the equivalent database schema diagram for the student table is shown in this slide. So what is the inference? So here you are having a table called the student. So for this student table, what is the equivalent schema diagram? So this is the schema diagram associated with the table called the student. So as part of the student table, what are the fields you are going to have? You are going to have name, student number, class, and major. So if you take the prerequisite, you will be having the fields like course number and the prerequisite number. So see here, for a prerequisite, you will be having the the course number and the prerequisite number. So this is the diagram. So this is the equivalent schema diagram for your student database. Now, how will you define a database schema, or what is the meaning of the term schema? Now, what is the requirement is, you need to differentiate between two terms, namely description of the database and the database. Both are not same. Your description is different from your database. So, you can represent the description of the database in a diagrammatic form, and that diagrammatic form is called as your database schema. Okay. So the description of the database is called as what? Description of the database is called as your database schema. So this will be finalized in the beginning stage itself. So the thing is, see, we are not going to have a situation such that today we will be having 3 fields in a table, tomorrow we will be having 4 tables, day after tomorrow we will be having 5 tables. So you are going to use the database for a longer duration, or you are having a life cycle associated with your database. So the structure will be finalized initially, and that structure will be retained throughout the life cycle. So you can change the structure, but you cannot change the structure on a day-to-day basis. So for displaying this schema in a diagrammatic form, we are going to use some convention. So your displayed schema is called as what? Your schema diagram. So actually, as part of this schema diagram, so what we are going to specify is, we are going to specify the record structure. We are not going to represent the what? We are not going to represent the actual data. Clear? So you will be having what? Only table name and field name will be displayed as part of your schema diagram. So what is the content inside the student table, that will not be displayed as part of your schema diagram. So now you are having some limitations. You are having some limitations associated with this schema diagram. So what is the limitation? See, if I say this is the schema diagram associated with the student, what is the basic information you can infer? You can infer you are having 4 fields, and name of those 4 fields is name, student number, class and major. Apart from that, you cannot infer any additional information. So what is the data type? So what is the size? What is the relationship? Whether you are going to have any constraint. So nothing can be inferred from this schema diagram. So that is the major limitation in your schema diagram. Okay. So now in your schema diagram, display only the name of the record and what is the field name. So it is not going to specify the data type, what is the relationship and what is the constraint. See, suppose if you are going to have a constraint like this. So a student majoring in computer science must complete this course before that particular year. So it is not possible to represent these type of constraints as part of your schema diagram. So that is the major limitation in your schema diagram. Clear? So your database schema is used to represent the structure. It represents only the field name, table name and field name. So the information about the data type, size, relationship, constraints. These things will not be incorporated as part of your schema diagram. Now, so next one is database state. So how will you define a database state? So actually your database state refers to the content what you have stored inside the database. So what is the actual data stored inside the database is called as the database state. Then how this database state differs from the database schema. So if you see the next point, so your database state changes frequently. So whenever the user interacts with the database, whenever you perform an addition, whenever you perform a deletion, whenever you perform an updation, so for each and every operation, the content of the database will be changed, or the state associated with that particular database will be changed. Now, precisely what is the definition? If I give you a database and if I ask you what is the current state of the database, how will you give the state associated with the database? So your database state is nothing but the snapshot related to the particular point. By 10:30, what is the content? That is the database state. By 10:35, what is the content? That is the database state. So whenever you perform as an end user, whenever you perform an insert or delete operation, then your database will move from one state to another state. Your database will be moved from one database state to another database state. So this represents the what? Your database state gives you the instances. So currently, how many records you have as part of the database? That is the instance. Suppose if I say that by 10:20 I am having 10 records. So that is the current content that is available inside your database. So your database state gives you the what? Your database state gives you the current set or the instances at that particular moment. So what? So the thing is, whenever you create a database, so the thing is, see, you have created the database, but you have not stored any record, or you have not populated the data. You have not populated the database with any records. So initially, your database will be in the empty state. So whenever you create a new database, you will specify the database schema to your database management system. So at that point, your database state will be what? Your database state will be empty, or your database will be in the empty state. What does it mean? You have not stored any data as part of the database. So from the empty state, when your database will be moved to the initial state. So initial state means this is the state. So when you have loaded your database with the first set of input, or when you have loaded the, see, suppose I have created the database and I have stored some 2 records. So it is called as the initial state. So from that point, whenever you are going to perform an insertion or deletion, or in general, if I can say it as an update, your database will move from one state to another state. Okay. Now, with respect to this database state, what is the responsibility of your database management system? So, your already, if you remember the characteristic we have discussed about the atomicity and durability, consistency. So, here it is related to what? It is related to your consistency. So, what is the responsibility of your database management system? It is responsible for moving the database from one consistent state to another consistent state. So here consistent state refers to what? It should not violate the structure associated with that particular database. So that is the idea behind your consistent state. Now, so we will be using 2 different terms, namely intention and the extension. So with respect to database design, one important task is to specify the correct schema to your DBMS. So the thing is what? So the entire operation of your database depends on this what? Depends on this schema. So you need to be careful while designing the particular schema. So this schema information will be stored as part of what? As part of your DBMS catalog. And whenever there is a need to execute a query, this schema will be referred. So what we are going to do is, so this schema, so we are going to refer this, another name for your database schema is called as what? The intention. Actually, the data what you are going to store inside the database is an extension of your database schema. So we are going to refer the database state as a what? Your database state is nothing but an extension of what? Extension of your database schema. So, and finally, the last terminology is schema evolution. So I have given the explanation for this term in the beginning itself. Okay. So the thing is, so by seeing the previous discussion, immediately don't come to the conclusion. Once the structure is finalized, it is not at all possible to modify the structure. Or as a database administrator or as a database designer, it is not possible for the database administrator or database designer to modify the structure. That is not the case. So if there is a need, what you can do is, it is permissible to modify the structure of the database. Okay. So your database schema is not supposed to change frequently. That's what I told you. On a day-to-day basis or on a hourly basis, we are not going to modify the water. We are not going to modify the structure of the data. But in some rare cases, so already what I told you, you are going to, the life cycle associated with the database is going to be large. So you are going to use the same database for 5 years or 10 years. In that case, after some 1 or 2 years, there may be a what? There may be a new requirement. You want to satisfy a new requirement as part of that particular application. So what is the need is, if you are going to, for incorporating a small modification or for incorporating a minor modification, if you are going to start designing the database from the scratch, it is going to be a what? It is going to have much cost. It is going to have a huge impact on your company or on your organization. So what we need is, so your database management system should provide support for DBMS evolution, or that is your schema evolution. So what do you mean by schema evolution? Your database management system should provide support for modifying the database schema. See, suppose you are having if you see this example, you assume that you are having a table called the student. So initially you have identified some fields related to this table. Your date of birth is not part of the student table. So you want to join, you want to perform join, or in the later case, in order to reduce the join, or in order to reduce the time, you feel that if date of birth is part of this table, it will be helpful. So you want to modify the definition of the student table by incorporating one more field called as what? By incorporating one more field called as date of birth. So this mechanism is called as what? Modifying the existing structure of your database, or modifying the current content of your database schema is called as schema evolution. So for this, what is required is, you need appropriate support from your database management system. So your database, most of the modern database management system provides support, or they have some operations for schema evolution. So what they are trying to say is, see, what is the important point you need to notice? Whenever if you are going to modify, there is no need to while the system is in operation. So there is no need to switch there. There is no need to go to the maintenance phase and all. Okay. So without affecting the normal day-to-day operation, it is possible for you to It is possible for you to modify the structure of the database. So that functionality is available in the modern database management systems. So as a summary, these are the topics I have covered as part of today's lecture. So I have started with the definition of a client-server architecture. So basically, we want to create a distributed environment. So with the multiple computers, each and every computer with some specific responsibility or with some specific task. So what is a data model? What is the purpose behind the data model? Based on the concept, how you can categorize the data model? How will you define a schema? What is the difference between a database schema and database state? What is an instance? What is the limitation? So diagrammatic representation is called the schema diagram. What is the limitation in your schema diagram? So what is the meaning of intention and extension? Finally, I have concluded with the terminology called as schema evolution. So thanks for your participation. So if you have any doubt, you can ask me, I will explain. Related to today's class or related to today's lecture, if you have any doubt, you ask me.